Hello, I'm Rebecca the Maths Lady, and in this video I'm going to show you how to make sure your child makes really secure first steps with multiplication and becomes fluent and flexible and confident with their tables. So in this video we'll be looking at how you make sure your child really understands what multiplication is, how we help them understand why you can do it in either order, and then we'll look at how children become fluent with their tables. First of all, learning to skip count them, then becoming more fluent at skip counting and learning some shortcuts, then exploring all the table shortcuts, and finally looking at how children become completely fluent with their tables. Here's your shortcut if you already know all that and want to skip straight on to your next video, which is all about short multiplication. Okay, let's get started with the basics of multiplication. If you show your child a simple multiplication, let's say 3 times 7, do they actually know what's going on? Do they know what we're trying to do there? Let's look at it. 3 times 7. They need to be able to tell you either that's 3 lots of 7 or that it's 7 lots of 3. But let's assume it's 3 lots of 7 for now. They need to know that they are trying to count up the total of 3 groups of 7 objects. And they should be able to complete multiplications like that by making their groups and counting the total. And if we get rid of the objects, they should also be able to cope with the idea that 3 times 7 is 7 add 7 add 7, and that any multiplication can be written as a repeated addition where the second number is added together this many times. Or perhaps it's the other way round. There's been many feisty discussions on maths education forums about that. Which brings us to our second point. It doesn't matter which order you do the multiplication in. But your child, having an inquiring mind, is going to ask you, why doesn't it matter? So you're going to need an answer. First of all, it's worth appreciating that it is a surprise that order doesn't matter. If we take 2 bead strings and we do 3 lots of 7 on 1 bead string, there's 7, 14, 21. And then we do 7 lots of 3 on the other bead string, it does also come to 21. But it's quite a surprise. Well, it's probably not to you because you're an adult and you've been swapping the orders of multiplication for years, so it's just second nature. But it's not actually obvious to a child. You do need a way of explaining it, and there's one way of explaining it that works really well, and that is to organise your object as a rectangle. So our first 7 we make into a row of 7. Our second 7 becomes the second row of 7. And the third, and there we can see our 3 7s. But is that 3 7s or is it 7 3s? If you just turn your head sideways, you should also be able to see 7 3s. And that's always the case with any multiplication. If you arrange it the way you first intend it in rows, you can see it the other way around in columns. And that's always true. We can generalize it. The first number is the number of rows, the second number is the length of a row, and it works the other way around too, because that will give us this many columns of this many beads. So just like addition, but for very different reasons, multiplication is also commutative, which means you can swap the order. But remember, with subtraction, you couldn't. It didn't make sense. And I've introduced that idea really early because right from the beginning, parents and teachers say things like, what are 10 2s? And they expect an instant answer, it's 20 because 2 10s are 20. Because that's how they do it. You've just blown the mind of a child who doesn't actually understand the commutativity of multiplication. You've taught them that multiplication and therefore maths in general are magic. They're about spells you just have to learn rather than about understanding. So we need to establish that understanding of why you can swap the order of multiplication. And the answer is that. You organise the multiplication as a rectangle, you turn your head sideways and you can see it the other way. It's always true. We have whole classes of children discussing this and the teacher says, "Why can I swap the order of that multiplication?" And the whole class goes. And that is fine by way of an explanation because it makes deep sense and it always works. Okay, step 1 of learning tables is to get children skip counting their tables, which means they're counting in steps. So skip counting the 7 times table would be 7, 14, 21, 28, and so on. Now we start with the 2, 5 and 10 times tables because they're beautifully structural. If we use a bead string, and if you haven't got one, you can find worksheets of these for free download in my Facebook group, which is Expert Primary Maths Teaching, or through the links on my channel, then you can see 2s always fit within, 5 of them fit within one colour. We can see them. And then we have a colour change for the next 5 2s. So once you've learnt this structure of the counting beads, you can see, visualise the 2 times table and similarly the 5 times table. Beautiful 5s within 10, and then we have a colour change. And of course the 10 times table. If you do this a few times with children, they will have a beautiful structure in their imagination to support their thinking as they first skip count and then start to say 1 5 is 5, 2 5s are 10, 3 5s are 15, 4 5s are 20, 5 5s are 25, all the way up to 10. And if they've forgotten which number of 5s they've got up to, they just look at their fingers and they instantly know. So that's the 2s, 5s and 10s. And then it gets harder for the rest of the tables because you can't just see it as you can see those. So children need to do a great deal of work skip counting their tables again and again. Let's look at, say, the 6 times table. No 6s are nothing. 1 6 is 6, 2 6s are 12. Now here we added 6, we're doing that every time, but children need to do this in 2 steps. They need to use 4 of the 6 to fill to 10 and know that they've got 2 of the 6 left. We covered this on the number lines video. Here's a link to it now if you need a little more information on that. 12 add 6 is 18. The 2 of the 12 add 6, they should be able to see in their fingers. Then we've got 18, we've got to add 6, so we use 2 of the 6 to get to 20. And then there's 4 left of the 6, which will take us to 24. And we can also use bead string to support thinking and help children see those colour changes. But what's not okay is if children are counting on 1 at a time. That's not going to be fast enough. So if you're working with a child at this level, it's worth downloading some number lines worksheets or scribbling your own. It's very quick to do, and getting them doing lots of exercises where they are writing out their tables, adding the same number each time and becoming fluent at it, and certainly not counting up in ones. And they're going to gradually become more fluent at this, and then we want them to be able to put that down and do this in their imagination while they're using their fingers to keep track on where they are. 1 8 is 8, 2 8s are 16, 3 8s are 24, 4 8s are 32, and so on. As they work on this, they'll gradually start to see some shortcuts because they'll see which results are next to each other. 10 times the number is easy to do. They'll see the pattern of just adding a 0, so they'll know that 10 times 6 is 60. And so you can puzzle out that 9 times 6 is going to be 54 because it's going to be 1 lot of 6 less. Let's consider another table, 8 times table. Put 8 times here, so we've got keep a track on what we're doing this time. Well, they know that 80 goes there, and they'll pretty quickly see that 40 goes here because it's halfway. That's 5 times 8. So we can work out 6 times 8 is 48 without going through all the other results. And we can also work out that 4 8s are going to be 32 because they're 1 8 less than 5 8s. Children start to see these shortcuts, and they're important shortcuts that they're going to need. But it's not easy to see all the shortcuts on the number line. There are plenty that your child might be using. And if they're coming up with shortcuts, that's great. was walking to school with my daughter and just checking some tables with her. And I asked her what 6 sixes were. She had a think and she told me they were 38. Now, it's tempting to say, no, you're wrong. It's better not to, just to say, can you explain to me how you did that? And what she said to me, well, I could see it was 3 12s. I could see 6 sixes were 3 12s, and 3 12s are 38. Oh, no, they're not. They're 36. And she was right in her thinking. Her thinking was really creative and powerful and deserved lots of praise, but that would have been missed if I'd just told her she was wrong. But how do you come to understand strategies like that your child is trying to tell you? Well, earlier I arranged counters in a rectangle to explain multiplication and why it was commutative, why you could change the order. It turns out that rectangles are really helpful. If we look at 6 times 6 as a rectangle of squares, 6 lots of 6 squares, suddenly you can see the 3 12s that she was thinking about. Just fold it. There they are. 2 6s are 12, and there are 3 lots of 12 in the total. I've also had children trying to tell me that 36 is 2 lots of 18, which it is. They're seeing the symmetry of it. If they're seeing that, they're doing great maths that they deserve credit for. So it's important that children come to see multiplications as being rectangles, where one of the numbers you're multiplying is the width of the rectangle and the other is the length. In this case, it's a square because it's multiplying the same number. And the answer is the total number of squares. And I will create a worksheet on that, on the foundations of multiplication, but that might not be for a couple of weeks after this video goes live. As we develop fluency with children's tables, we're doing some really important work that lays foundations for their future abilities with maths. Some people would tell you should go straight in and get children to rote learn their tables. It does a lot of damage because they miss steps. We can put those steps back in deliberately if your child has been taught to rote learn their tables. So for example, they need to be able to skip count fluently. If they've rote learned their tables, you can develop that skill by starting at a number other than 0. If we start at 3 and count in 8s, they'll be forced to become fluent in that skill as well. The next stage of fluency with multiplication tables comes as children work on short multiplication, which is explained in the next video. And then finally, to really put the icing on the cake of fluency, it's great for them to work on speed with some of the wonderful apps that are used to build fluency with tables, like Times Tables Rockstars, which is really age appropriate. You build your Rockstar avatar and you spend money you earn through doing tables practice on things you can use to personalize your little Rockstar in that app. And that involves lots of nice addition and subtraction that's age appropriate, as well as, of course, the tables practice. So your takeaways from this video are that children need to understand that multiplication is repeated addition. They need to understand that it can be done in either order and why that is. And then we need to work on building their fluency with tables, first by skip counting them, focusing on the 2, 5 and 10 times table first because they're structural, and then on the rest of the tables, making sure that each addition is done in no more than 2 steps. Then we start to look at shortcuts by relating results to the one next to them, and then also by looking at rectangles of objects and rectangles of squares to see other shortcuts that your child might choose to use. And it's a great idea to take time to encourage them to be creative with their tables strategies and to take the time to listen to the methods that they are trying to use, even if they're really unexpected. There are some great fun apps for tables out there, but I don't recommend that you use them until your child has explored all these strategies and built a fair degree of fluency. The apps and the rote learn practice are just the icing on the cake. It's so important if a child forgets a result, they can quickly rebuild it because they will forget. And if they rote learn results too soon, they don't bother to learn the strategies because they don't need to. The next video is on short multiplication, and in that video I'm going to explain a little more on how we build fluency with tables results. If you've any questions, please put them in the questions below the video. And if you've got friends who you think would like these videos, please share them with them. Let's make sure all our children deeply understand their maths. If you've been watching the series straight through, you've completed 10 videos now. Only 10 to go, you're halfway through. Well done. Hope to see you again soon. Bye for now.